Welcome back, everybody. Today we are carrying on the work that we did yesterday about proving parallelograms, and we talked about 5 different ways that you could prove that a quadrilateral is actually a parallelogram. The exercises that you did yesterday all asked you to do that based on numerical values, so they'd give you either a side length or an angle measurement, and you'd have to use those to do your proof. The exercise that I've asked you to do today, in exercise 3 in your textbook, asks you again to prove parallelograms, but this time you're going to do it without numbers. So let's see an example of how that works. This example is from your booklet, again your geometry booklet we've been referring back to. This is page 14, number 7, and just like before I've just redrawn it so that it's a little bit bigger and we can work with it. Okay. In this problem, they say that ABCD and ABOE are already parallelograms, and they want us to prove that EAOD is also a parallelogram. So to start this problem, I'm going to start by highlighting the quadrilateral that we want to prove. So that's EAOD. So this is the one that we're interested in. And we also are given 2 other parallelograms that we're going to work with. So you could highlight those, but I just find it gets a bit complicated with all the colors. So let's rather use another pen in a different color to draw the properties of those parallelograms and see what we can figure out. So looking first at parallelogram ABCD, we can see that they've given us a hint by drawing the diagonals in of this parallelogram. So I'm going to start by showing that the diagonals of a parallelogram are bisected. The other parallelogram they give us is ABOE, so ABOE, but in this parallelogram we only have one diagonal that's drawn in, and it doesn't have a midpoint, so I don't really think I'm going to use that property in this bottom parallelogram, ABOE. Alright, so in this parallelogram ABOE, instead of looking at diagonal properties, I see that I've already got side lengths that drawn in from before. So let's see if we can add to that. In ABOE, I have this side OB is equal to AE, and I have OE equal to AB. And we'll see if that helps us in a second. Right. So already looking at my highlighted quadrilateral, the one that I'm trying to prove, I have one pair of opposite sides equal. So if I were able to show that ED is equal to OA, then I'd have both pairs of opposite sides equal, but it doesn't look obvious how I would prove DE. They haven't told me anything about this top parallelogram. What I should rather do is look again at ABOE, and notice that ABOE, because it's a parallelogram, it also means that its opposite sides are parallel. And if OB is parallel, that means that OD is also parallel because D is on a straight line with OB. So look what I have here. I have EA and OD as equal and parallel. And we talked yesterday about that case 5, that sort of unusual one, where we have one pair of opposite sides equal and parallel, so it has to be a parallelogram. So we've done it. Now we just have to figure out how to write it down. Okay, let me try and cover this up. And we can see that. Okay. All right, so again, we start out with our RTP statement. Remember, that stands for required to prove. I'm trying to prove that EAOD is a parallelogram. And again, I said that this portion, EA equals DO and EA parallel to DO, that's optional, but I like to show it because it gives me a framework for how I'm going to present my argument. Okay, so we started off, DO was equal to OB because diagonals of a parallelogram. I like to write which parallelogram I'm talking about, ABCD, but if you just wrote diags of Parm, you would get the mark there. I have OB was equal to EA because they're opposite sides of ABOE. Therefore, DO has to be equal to OA because both of them are equal to OB. We then said that OB and EA were parallel, opposite sides of a palm. Therefore, OD was also parallel. And the book likes to do something like DOB is a straight line. But to me, it's quite obvious that DO is going to be parallel. So even if there's no reason here, that's not a train smash. Therefore, our final conclusion statement, EAOD is a parallelogram. One pair of opposite sides equal in parallel. Nice and simple, no numbers required. You just need to know your properties of a parallelogram. Okay, from here you should be able to do exercise 3, A through C I assigned you, and if you really bored and want to do D through F, all the better. I will upload the solutions later on. Good luck!